The displacement of a particle moving back and forth along a straight line is given by the equation of motion s equals 2 sine pi t plus 3 cosine pi t, where t is measured in seconds. Find the average velocity during each time period. In this example, we'll use the average velocity formula separately for each example for each time interval, rather than using the h method that we used in the previous example. Just want to show you that there's more than one way to approach these problems. So the average velocity, again, the formula is the change in position over the change in time. So we have s evaluated at 2 minus s evaluated at 1 all over the change in time 2 minus 1. This time we'll use the calculator. In the numerator, we have 2 sine of pi times t, which in this case is 2, plus 3 cosine of pi times t, again is 2, minus s of 1. Since s of 1 is being subtracted, I'm going to have a second set of parentheses so that we make sure we include both terms. 2 sine pi times 1 plus 3 cosine pi times 1. Close off the argument on cosine and we'll close off the numerator. And then 2 minus 1 for the denominator. And this is going to give us 6. And that is centimeters per second. In our next example, we're looking at the average velocity of s of 1.1 minus s of 1, all divided by 1.1 minus 1. Since the previous command is already in the calculator, I'm going to use the second enter function to bring up the previous command. And now all I have to do is go in and edit those time intervals. So instead of 2, I'm going to change this 2 to a 1.1. We need to use the insert function to get that decimal and 1 in there. Do the same thing on this too. We have 1, then second insert 0.1. The rest of the numerator is okay because we're still subtracting s of 1. And then in the denominator, we need to change the 2 to 1.1 minus 1. And this time I'm getting negative 4.71 roughly centimeters per second. In the next example, we have the average velocity s of 1.01 minus s of 1 all over 1.01 minus 1. Again, we'll use the calculator to calculate that. So second enter will bring up my previous command. I just need to go in and edit those time changes. So instead of 1.1, this time we won't 0, 1. We can use the second insert to give us that extra 1. Then change the denominator. Enter, and this time we get negative 6.13 roughly centimeters per second. We'll repeat this process for our next time interval. S evaluated at 1.001 minus S of 1 all over 1.001 minus 1. Back to the calculator. Just need to go in and change those values. Need to insert an extra 0 here. Here as well. Then in the denominator, we also need to insert an extra 0. And now we're getting negative 6.27 roughly centimeters per second. And we could continue doing this. I know the directions don't say it, but if we wanted to do it again, we could get an even closer approximation. Go in and add another 0. Get an even smaller time change for each of these. This time we get negative 6.28. So using these, let's estimate the instantaneous velocity. Remember, the instantaneous velocity is what we're approaching. As we make our time intervals smaller and smaller and closer to that starting value of 1, it looks like we're approaching something. It looks like we're getting closer and closer to negative 6.28. So it looks like the instantaneous velocity is negative 6.28 centimeters per second.